Good morning, students. We have proceeding our chapter Work and Energy, and today let us discuss numericals related to work and energy. And especially today we will discuss potential energy. So, students, see one question is here: a body of mass 5 kg is raised to a height of 80 meter. Calculate its potential energy. So let's see what is given. First of all, we are seeing the given. So what is given? Mass is given 5 kg. Height is given 80 meter, as it is raised at certain height. So naturally, G will be 9.8 meter per second square. As we are knowing, when body is raised against the gravity, potential energy formula we have derived mgh. We have done this one in previous class. So, m we have 5, G we have 9.8, H we have 80. When you will multiply all this, we will get it 3920 joule. So, its potential energy is 3920 joule. Let us see the next question. Another question. A girl sits and stands repeatedly for 5 minutes. Draw a graph to show the variation of potential energy of her body with time. Here we have to show that when girl sit and then stand, sit, stand, sit, stand. When she stand, potential energy increases. When she sit, potential energy decreases. So let us see how we will show the variations. So first of all, draw the graph. Students, I think you are remembering that when I was teaching the first chapter, I have told you that whenever we are drawing a graph, we are taking two axes, x-axis, y-axis generally. We have to think about it that in which axis, which physical quantity should be manipulated. So always remember, x-axis is for independent variable and y-axis is for dependent variable. So here we have to show the graph between sitting and standing for 5 minutes. That means time and its potential energy. So time is represented in x-axis because it is independent variable. And time is for 5 minutes. So let's see 1, 2, 3, 4, 5. How we will show it? So girls sit and stand. Let us start. Sit, stand, again sit, stand, sit, stand, sit, stand, sit, stand, sit. So like this we will show the graph. Here y-axis is representing potential energy. Potential energy. Let us see the next question. See the next question. If you apply 1 joule of energy to lift a book of 0.5 kg. How high will it rise? So we have to find out the height. Let's see what is given. Given potential energy 1 joule, mass 0.5 kg. G here it is given 10 meter per second square. We have to find out height. So apply the formula of potential energy. Say here, we know potential energy is equal to mgh. Put the values. Potential energy is 1 joule. Mass is 0.5 kg. Value of G is given 10 and height we have to find out. So let us find out the height. This implies height is equal to 1 by 0.5 into 10. When you will solve this, then you will get 0.2 meter. So we will get this answer. Let us see one more question. Next question is, an object of mass 40 kg is raised to a height of 5 meter. Above the ground. Calculate its potential energy. So, let us solve up to here, then we will proceed again. Given, first of all, mass is equal to 40 kg. Height 5 meter. We know the value of G 9.8 meter per second square. We know the formula of potential energy mgh. We have 40 into 5 into 9.8. When you will calculate this, you will get the answer 1960 joule. We have got this potential energy. Now let us proceed the second half of the question. If the object is allowed to fall, find the kinetic energy when it is halfway down. Means when it comes, it's halfway. H was 5 meter. And when we have to calculate its kinetic energy, let's its height be h dash and it is halfway, that means 5 by 2 meter. So I think you have understood for which case we have to calculate its kinetic energy. So let's check it. Object falls halfway. So we can write this as h is equal h dash. Let us take the new height from downwards. So h dash h by 2, that is 5 by 2 meter. For calculating kinetic energy, we have to find out its velocity, and its velocity is not given. So let us calculate from the equation of motion. We know the third equation of motion, that is from third equation v square minus u square is equal to 2g and s, that is s is the new one, h dash. So here u becomes 0 because it was raised at certain height, and its initial velocity, when it starts falling, its initial velocity is equal to 0. So here we put the value u0. So v square minus 0 is equal to 2g h dash. That means v square is equal to 2 into 9.8 into 5 by 2. So what you have got for this, your answer, that is 2 cancelled. So we will get it 49 meter per second square. We have got v square. We are having mass. So naturally, you know the formula, kinetic energy is equal to half mv square. We can calculate it. So see students here. Kinetic energy, we will calculate this. So see, kinetic energy is equal to half mv square. Half m we have 40 kg and v square we have got 49 meter per second. We have 49 meter per second. So 40 into 49 to 20. So we will get the answer 980 joules. So this is the answer. Okay, then you practice the numerical.